All right, Math 5130. Something I've tried to make a point of is when we run these statistical tests, we get these p-values. And these p-values really don't mean much to us. I mean, we can talk about statistical significance and uh, whatever, but unless we understand the context, and the context is within the null and alternative hypotheses, because the p-value makes decisions about the believability of our claim in the null hypothesis. So when we have something like this, I think it's a good time to just kind of pump the brakes and step back and think about what we saw previously. We've got a lot going on. We've got 1, 2, 3, 4, 5 p-values there that we need to place in proper context. So the first one that I get, it's kind of hard to see, would be the null hypothesis. And for all of this right here, you have to remember that we have sample data, and I'm just going to present it in the simple linear regression case, although we're in the multiple regression world now. And we're using this information to predict, make estimates of the population model. So we have our sample statistic making an estimate of our population parameters. B0 is estimating beta 0. Kind of think of using X bar to make an estimate of mu, using the sample mean to make an estimate of the population mean. That's what we're doing here. We're taking our sample intercept to make an estimate of our population intercept, and we're taking our sample slope to make an estimate of our population slope. And you should see that this can easily be, we need to put different x's there, to be extended into the multiple regression case, which is what we're doing. So for intercept, the first null and alternative hypothesis that we would have is that our beta 0 is equal to 0 and our beta 0 is not equal to 0. So here we have statistical significance at the 0.05 level, so we would reject the null and we would conclude that the excuse me, that the alternative hypothesis is more believable. The second that we have is we have the beta estimate for age. So in this case, we would have that the null hypothesis is the beta, I'll just do it this way, is equal to 0. And the alternative hypothesis is that the beta for age is not equal to 0. We do not have statistical significance for beta, so we conclude that the alternative is more believable. I'm sorry, the null is more believable than the alternative. The third hypothesis that we have is for HF underscore SCI, works the same way. We have a null hypothesis for this, I'll just use HF, predictor. Sorry, I'm not talented enough to speak and write. So we have a null hypothesis for this individual predictor. So these up here, they take the intercept and the two predictors individually of each other, right? That's kind of, we just isolate those. And in this case, we have statistical significance, so we would reject the null and conclude that our coefficient for HF for the population model is not equal to 0. Now the next thing we get into is this line right here. And this line right here takes in consideration both or, in general, all of our predictors. So the null would be that beta 1 is equal to beta 2 equals 0. And the alternative would be at least 1 beta sub I is not equal to 0. Now, we have statistical significance, so we're going to reject this statement. And we're going to conclude that at least one of our predictors is not equal to 0. Now you might say, well, we looked up here and we see that, right? Yeah, it's not that's not the way it works. These coefficients are isolated. They're considered individually in these individual test of hypotheses. But this line for the F statistic looks at the set of predictors collectively. We don't separate the two. So we consider having the beta for age in the model along with the beta for HF. So that's the difference. And I don't know why I put 2 there. That should be 4. The fifth one I did is I ran a correlation test down here. And you can see, again, we have another p-value, so context is important. So what we're looking at here is that rho is equal to 0 versus rho is not equal to 0. The correlation coefficient for the sample is used to estimate the correlation coefficient for the population. Sample, estimating population. Sample, estimating population, right? Sample, estimating population. So is the population correlation coefficient something other than 0? Well, we do not have statistical significance, so we do not reject this statement. So based on the sample data, we cannot conclude that the population correlation coefficient between SSQ and age is different than 0. So we do not have statistical significance. All right, gang, hope this helped.